So, on the bench today we have a CB amplifier, and I normally wouldn't bother repairing something like this, and if it is going to be expensive I won't bother. So, story is, been left in a garage for about 10 years, a rather damp garage, and it's got all sorts of nasty things inside it, dead insects and a fair bit of corrosion around the screws. So don't know what's wrong with it at the moment, but amazingly we have the instructions with it, and it says it's rated for 200 watts AM, 400 watts single sideband, but I suspect 100 watts would be the maximum you get out of it, but who knows. And has a rather peculiar switch on it which is called modulation, and according to the position of the switch you get more gain, and on P6 with 2 watts you're supposed to get about 60 watts output. So I suspect that well, I know it is, having looked at the circuit diagram, that modulation switch is just a switchable attenuator. It's a stupid thing to call it a modulation switch. I suppose what they mean is if you overdrive it then the modulation will be distorted. But yeah, so it's just a switchable attenuator, that's all it does. And I got the whole circuit diagram, so that's a bonus. What else can I say? Yeah, it looks, was old to hoover it out really, but I'm going to just turn it on and see what it does. I've got it wired up. I've got it wired up to a power meter and a dummy load, and I shall stick my signal generator into it. But first of all I'll test it with no input. So just turn on the 12 volt power supply, and it's drawing 44 milliamps, which is not very much. Okay. Being a linear amplifier, it will have obviously some standing current, and it should draw a fair bit of current. Wow, I don't know, 100 milliamps, maybe more. Anyway, there's an adjustment here, and that'll be for the biasing. Let's have a look on here. Yep, there's a pot there. It's okay, pot. The bias is the first RF amplifier MOSFET, and then it's just a conventional push-pull whatever transformer in and whatever. Yep. So if I twiddle that pot, yeah, I can make it drop to 30, and well, it goes right up to, I've now got 180 milliamps, but I can always turn that down again if necessary. So I think the next thing to do is turn the signal generator on, see if it does anything at all. Okay, so what I'm going to do is I'm going to use my signal generator, which is I'm fairly lucky with this generator we've got up there. Oh, I can't really see the screen, but anyway. Right, now I'm inputting 27 megahertz plus 20 dBm. and I don't know if you heard that, but if I turn the output from the generator on and off, the relay clicks, and there's an RF detector relay which senses RF, so it's fairly sensitive. If the fact that it can pick up 100 milliwatts of RF. If I do that again, it clicks on, so now it's in amplify mode rather than straight through. And on the ammeter, on the 20 watt scale, it's reading absolutely nothing. So it is clear that this thing isn't working. And what else can I do? I could switch it from single sideband to FM, AM, FM, and that makes no difference at all. So nothing's getting hot. It's now drawing 500 milliamps, which may or may not be too much. I mean, I can adjust it, take it down to about, that's about 200 milliamps it's drawing now, but that's the driver MOSFET, and that's not getting particularly hot, and nor any of the others. So I think maybe I need to establish if the relay is working properly and if the RF is getting to the input. Over here we've got a little transistor, that's the RF detector that switches the relay, and so that's the input signal. Just gonna, no, I'll leave that where it is for the time being. I'll put this in continuity and I go to the input, what's it say on the circuit? Right, okay, so there's no capacitors in coupling or anything like that. So if I go onto the input socket with my meter, I should, somewhere around here, find continuity. Okay. And that it means that the signal's being routed through to this switch. Alright, you can't see the switch, but that's the modulation control, which is effectively an attenuator. So I know that it's getting RF through from this socket to the attenuator switch, and it's coming out of the attenuator switchboard and going to the first MOSFET. So I wonder if the other connection's working okay on the relay. So on the output stage, we've got a connection there which comes from the RF socket when it's in transmit. That goes to a couple of inductors and 247 ohm resistors. So if I can check that. Checking the circuit diagram. I can see 247 ohm resistors there. There's also two on the other stage, because this is two stages of amplifiers which can be combined into the final output. So that's the output anyway. So in theory I should get continuity on one of these. Yeah. And if I turn off the generator. Relay clicks out and we have no continuity anymore because it's going straight through. Yeah, in other words, it's rerouting it out. I think the best thing to do with it really is to hoover it out, because it doesn't look very nice at all. It's got all sorts of nastiness in there. And then maybe disassemble it, possibly check the MOSFETs, and I can check with a scope on the first MOSFET. In fact, I could do that now. I could stick the scope on and see if I'm getting any RF coming out the first MOSFET stage. So I'll get the scope warmed up. Okay, I just noticed something. With no RF input, it's only drawing 49 milliamps. If I turn the generator on, I've got 200 milliamps being drawn. So that sort of infers that maybe the first stage is working. So I'm going to try and get on the scope. And have a look on the input. That's basically the signal coming in on the socket, which is 1 point something, 1.6 volts. So if I go to the first MOSFET, on the pins of the first MOSFET, I'm getting not a lot, except a DC offset. DC, AC coupling is what we want. Yeah. Well, that's on the gates. That's on the gate of the MOSFET, which is more or less what you expect. And on the drain, we get that. So maybe the first stage is working, although it looks a bit distorted. If I look on any of the others, there's nothing. It's on the other drains. That's the gates, the gate of the power output MOSFETs, which is good, and nothing on the drain of any of them. The gates are fine, there's plenty of signal at the gate, but nothing on the drain. So I think the first stage is working, but the rest of them aren't for some reason. So I'm going to clean it out first of all, then maybe take it apart. So back on the CB amplifier, I'm trying to get this circuit board out to check some of the components, and there's a bar goes across here that has to come out because that holds the MOSFETs down. I've disconnected all the wires from the various sockets, but there is one screw down here which is absolutely seized up. It's the usual problem, steel into aluminium, to get any sort of corrosion, and it's a bad result. It seems very wet as well, or oily on top of the MOSFETs. Strange. Don't know if that's a good thing or a bad thing. Well, it's not a good thing, is it? But this screw is a real problem. I nearly just damaged my screwdriver, I put so much force on it. The only thing I can do now is try and grind it away with a Dremel. I don't know why I'm really bothering with this, because what point is there in this amplifier? but it's a challenge and I like trying to fix things. So I think I would have to get medieval on its arse and grind it. So I've got it wired up again on the bench, and I'm putting a signal in here, which is basically the input to the first amplifier stage after it's been through that attenuator. And it was, when I turned the generator on, it was drawing quite a bit of current, more than it was with the generator off. So checked on this first stage, and it was doing more or less the same as it was before. But because there's no heat sink on it, I went and touched the case, and it was absolutely red hot. So I have to turn it off quickly, and I burnt my bloody finger. And what else can I say? I've been around all the diodes, and they all test out good in circuit. They all measure 0.6 one way and open circuit the other. So I have a horrible feeling it could be the all these MOSFETs in the second stage. So I might just drag one out and test it out of circuit. So I got one of the MOSFETs out, and I measured its terminals with a meter, and they're all open circuit. But my favourite way of testing MOSFETs, because I don't have a component tester that will test them, if they're N channel, stick voltage on the drain, which is the tab in the centre pin, put 0 volts on the source, set the current limit on the power supply to not too high, about 50 milliamps, and they're such high impedance devices, all you need to do is touch your finger between the gate and the positive, and it will turn the MOSFET on. I'll demonstrate it. It's my meter. Bloody arm. My power supply, and the bloody thing won't. Oh, it's crap. Anyway, there's the power supply. We're drawing no current at all at the moment. Now I'm going to touch one finger on the positive and one on the gate, and it immediately draws 50 milliamps. And now it's halfway turned on even when I take my finger off. So I touch my finger now between the negative and the gate, and it turns off. That's because they're such high impedance input devices. So that MOSFET's good. So I don't really want to drag the rest of them out, and it'd be hard to test them in circuit like that. But I'm going to assume they're all good, so it's a bloody mystery. Okay, well, I'm just going to do a resistance check between the gate, drain and source on the other MOSFETs, which are still in circuit. And this is, so I'm on the so I'm measuring between the gate and the drain, which is 7.4k, and the source 3.7k. Next MOSFET, drain to gate 7.4, 3.7k. Next MOSFET 7.4, 3.7. Next one 7.4, 3.8, slightly different. Next MOSFET 7.4k, 3.8, and the last two 7.4, 3.8, 7.4, 3.8. So I think all the MOSFETs are fine, because they usually go short circuit when they blow up. So it's a mystery to me. I should have to continue looking around and to get that other one back in again, which will be difficult because it's plated through holes. But anyway, whatever. So I'm still poking my way through this bloody amplifier. and I've established the first stage works, and I know the main power MOSFETs work. I've put the what's his name, the driver on a heatsink for the time being, because it gets extremely hot when I'm testing it with RF going through it. But it was drawing so little current in standby mode. That's what perplexed me. I had a feeling that these MOSFETs, power MOSFETs, power output MOSFETs, were not being biased properly. There's no bias adjustment, unlike on the first stage. So I checked on the gate, and I'm only getting 1.8 volts on the gate. I'd say that's far too low to bias on a MOSFET. So why is my question. As far as I can make out, this is the bias circuit. There's 3.7k in the top resistor, actually made up of two resistors stood up. Might be able to see that, and a diode which goes down, a reverse bias diode going down to earth. What's that for? I don't know. Most bizarre. So they form the first part of the you get plus 12 on here, and the bottom MOS resistor in the potential divider is 4.1k. So in theory you get about 6 something volts roughly. That's the bias point. It goes straight to the gate of the MOSFET. And there's no way I'm getting 6 volts. And this circuit's so hard to follow. Some of it doesn't make sense, some of it doesn't. I wonder if this is the right circuit for this actual amplifier, because there's no sign of those two series resistors that are in the bias line. There's a 27k, they're using a 27k coming off the 12 volt, and then that goes basically all the way through the transformer down to a 6k8, and that forms the bias, and that's connected straight to the gates of the MOSFET. The voltage you get at the junction of 27k and the 6.8k, because it's going straight through the short circuit turns of the transformer. So 27k, 6.8k. Well, there's no 27k or 6.8k in this device, so that doesn't make sense. But most bizarrely, if I lift that leg of that diode, the current goes up. The quiescent current with no signal goes up. So I'm on 167 milliamps at the moment, which is not a lot. Most of that will be going in the first stage in bias, and I always work on things when they're turned on. If I lift that off, I've now got 191 milliamps. Now how can that be? That's a reverse bias diode. That is the positive end of the diode, and the other end goes straight to earth. There's no AC present in theory at that point, so how can the diode, which is reverse bias, make any difference? And if I do the same thing on the other stage, disconnect that, it goes up to 219 milliamps now. And now if I go and check the voltage on the gates, before I was getting 1.8, I'm now getting 3. Just hang on a minute. I'm now getting 3.1 volts, which is more inclined to turn that MOSFET on. And on the driver, the voltage is 3.5 on the gate. So 3.1 seems more reasonable. Having done that, just a minute, okay, so having biased the MOSFETs on a bit more than they were originally, I just don't know how it could have ever worked with 1.8. and I've taken every component out, every diode, and checked them. That's all the other semiconductor devices on the board. The resistors aren't going to give you a problem. But now the results is when I turn on my generator, that's with 100 milliwatts, 20 dBm. So I'm not getting a watt, I'm getting 10 dBs of gain out of this amplifier. I still think it should have more than 10 dB gain. What's it show on the... it says, obviously it doesn't, I don't know if you can see, it doesn't go below 1 watt obviously. But at 1 watt, it should in theory give 20 watts. So it should have maybe 20 dBs of gain. 2 watts should give 80 watts. That's not linear, is it? But what the hell. I don't trust this Italian rubbish. That's what it basically is. So I'm not getting a watt out. Actually it's gone up 1.5 watt as it's warming up. Interesting. So I think that those output MOSFETs need even more biasing. So what I'm going to do now, turn the power off. I've got 2 crocodile clips here. Get in better with my... Right, there's my biasing resistors. One's, which you can't see very well, goes down to the board and is connected to the 12 volt line, and the other one goes to the gate, basically to the gate of the MOSFET. And so I'm going to what I'm going to do is clip on 12 volts onto the center point of that, eliminating that first resistor, giving it a bit more bias. And I will do the same thing on the other part of the power amplifier. So I'm basically eliminating that first biasing resistor, and turn the generator off again. Now I'm going to measure the voltage on the MOSFET, bias voltage. Right, then helps you turn the power on, doesn't it? Don't know what, I can't remember what I was getting before, but now I'm getting 3.2 volts on the gate, which again, and the clip's fallen off. All in all, I don't care if I blow this thing up, but it's interesting to get it to work. So I've now got a biasing voltage on the gate of 3.2 volt, which sounds a lot more promising, because the driver stage has got 3.5 on it. Even so, I still don't think that's enough bias. But I daren't put any more less resistance, because these are quite hot now. I think what I'm going to do is I'm going to screw it back in the case. But first of all, I'll show you the result of those crocodile clips and upping the bias. Back to the power meter. RF on. Hasn't made much difference. And if I take my power up to the maximum output of this generator, which is plus 25 dBm, I'm getting 5 watts, and that's roughly 300 milliwatts input. And that's back down to 100 milliwatts input. So I think I'm going to get it back in its box, and I think I should be getting more gain out of this thing. So I'm going to try rebiasing it with different resistors. Okay, this is all back in its box, and that red crocodile lead is There's the bloody input circuit. I'm monitoring the voltage on that first amplifier MOSFET on the 0.47 ohms, so I can work out the current going through the first stage. And I'm reading 0.5 volts across there, across this big resistor, 0.47, so it works out at roughly 100 milliamps, which I think is reasonable for the first stage. And we go over to the power meter. If you can see that miserable old power meter, I'm now reading about 4.5 watts for 100 milliwatts input. So what's that in gain terms? 4.5 watts, 100 milliwatts, 10 dBs would be 1 watt, 13 dB would be 2 watt. So 2 watt, 13 dB, 16 dB would be 5 watt, I think. Yeah, roughly something like that. But anyway, so what am I getting? About 13 dB, something, I don't know. But if I turn the power up now from the 100 milliwatts input to the maximum the generator will do, that is roughly 300 milliwatt, and I'm getting 8 watts. So I can do a calculation on that. 8 divided by 3, 0.7 times. No, I can't remember. Hang on, I'll do the calculation. Okay, 8 divided by 0.3 equals gain of 26, log of oh bugger, log of answer times 10. That's 14 dB of gain. That's not too bad, 14 dB of gain. Oh, what's it saying here? 1 watt should give you 20. That's 20 dBs of gain. So it's, but maybe they're being a bit optimistic on that. I mean, I can adjust the bias on the first stage. Oh, I've got a serious problem up here. I'm drawing so much current now. I've gone into current limiting. So that's back to normal. So that's 10 watts, yeah. 10 watts, let's do another calculation on that. 10 divided by 0.3, 33, log of answer times, that's 15 dB gain then. And it's drawing 5 amps. It's drawing 5 amps, 5 12s are 60. So it's drawing 60 watts to produce 10. Unbelievable. It's getting pretty hot. Getting fairly hot, the 10 watts output. Of course you're not going to be running, it's like all these amplifiers, you're not going to be running them flat out all the time, are you? Well, maybe CBs do, I don't know. There seems to be an optimum position for the bias on the first stage. That's turning the bias down and then up to maximum output, then increasing the bias up causes it to drop off again. So I'll leave it there. And I don't think I'll be fiddling with any more bias on the main power stages. It's doing 15 dBs of gain, and no, just turn the voltage up to 14, made no difference at all to the power output. Oh well, whatever. And this steady modulation switch, which is an attenuator, just drops it down. That's all that does. Turn it up full again. So yeah, I don't think that's too bad. 10 watts output, 300 milliwatts input. I'm going to leave it at that. Put it all back together, I guess. So final thing I want to do with it is check its harmonic output. So just a minute, turn the power on. So I'm reading 40 dBm, that's 10 watts, which you can see there. I go for a power attenuator to measure this, and 20 dB power attenuator, and that's the main fundamental on 27, 40 dBm, which equates to 10 watts. And we've got a second harmonic, right peak, next peak, and I've got peak. I want to do a delta marker, delta. So second harmonic. It's not a second harmonic. It's a spurious output. Just a minute. What am I talking about? Ah, dear, marker. Okay, that's the second harmonic at 50s, whatever, and it's 50 dB down. Because I'm on delta marker, I was confusing myself. Third harmonic is only 31 dB down. I guess that's not too bad. Increase the span a bit and see all the other harmonics. Marker normal, that's at 162 megahertz, and 162, that was a 108, so 10, 20, 30, it's only 40 dBs down on that one, and of course that one was only 30 dBs down roughly, so it's fairly crap in its filtering. But I looked up, when I saw the circuit diagram, I didn't really see much that looked like a low pass filter, but that's the way it's built, I guess, and it would be a hell of a lot worse if it was running 100 watts. Anyway, that's all I'm going to do with this thing, so hope you liked it. Give me a thumbs up, usual rubbish, and see you in the next video. So just when you thought it was all over, it isn't. I managed to find this old CB, and believe it or not, it actually works. And if we go over to the power meter, it's producing roughly 3.5 watts. And so I've now got it all wired up to see what the amplifier produces with 3.5 watts input. And I'm using my power attenuator as a dummy load. It's rated at 100 watts. And I'm using a slightly dodgy switch mode power supply, which sometimes works and sometimes doesn't, and says it puts out 23 amps, and the amplifier apparently is supposed to take 28 amps, but we shall see. So I'm going to turn on the amplifier, and whang, the needle flies across the screen, and I don't know if you can see, I'm getting just over 100 watts on the top scale of that meter. And I'm not going to run it long because something will probably blow up. I don't want to blow up my power attenuator because I'm very attached to that. But anyway, so that is finally the end of the video, and this thing obviously is now producing its full 100 watts output. I mean, it might produce more than that, but on single sideband it would be comfortably able to produce a bit more maybe, but not on continuous carrier. So there you are, that really is the end of the video now. Thanks for watching.